Good morning friends, welcome back. In that revision class, it is a revision of chapter number again 13 and we will see few things which is very important for this chapter. Okay, it is video number 65. Okay, see, in this video we are going to take first topic, and that topic is about nuclear force. Got it? Nuclear force. What is nuclear force? Nuclear force, it acts inside the nucleus. We know that what is there inside the nucleus. So inside the nucleus there are protons. So the force acting between proton and neutron, and in between neutron, right? That is known as nuclear force. Nuclear force. Any definition जो आपने आपकी होई तो how to give the definition? The force acting inside the nucleus between proton-neutron and neutron-neutron is known as nuclear force. Clear? Let us see its characteristics. Okay, so you can see that proton both having positive charge. So positive charge repel. But then also they are residing inside the nucleus, and you know that size of nucleus is 4 multiplied by 10 raised to -14 meter. Then also they are residing in that small size. Why? Because plus repulsive force, but then also it is there. It means nuclear force, its first characteristic. So it is a strong force. How much strong? It is a strong force and it is greater than Coulombian repulsive force. Is it? Okay. Second. What is that second? Right? That is known as saturation property. Means strong nuclear force acting between two adjacent particles only. Got it? Means if you will have 1, 2 and 3 protons, so let us consider the central proton. It applies strong nuclear force to that neighbors only. It means as distance increases, nuclear force decreases, and then nuclear force also becomes 0. So this is the saturation property. Okay, then third one is, see, nuclear force acting between that positive charge, between that electrically neutral as well as positive, and that electrically neutral means it do not depends upon charge, right? Not only that, from the saturation property it is very clear the nuclear force acting between that adjacent particles only. Because of that, it is a short range force. Got it? Then if it do not depend upon charge, so on which factor it depends, right? So it depends upon spin of that nucleons. Again, one more question: what is nucleon? right? Nucleon is a combined name of proton plus neutron. Means that nuclear force depends upon the spin of proton and neutron inside the nucleus. Is it? Okay. Then nuclear force is not a fundamental force. Not a fundamental force. Alright? Only this what you have to remember. It is not a fundamental force. It means it do not have equation. That means it not have equation. Got it? Fundamental force. Which are the fundamental force which having equation? For an example, gravitation force as well as electromagnetic force. So, in this point you can write nuclear force is not a fundamental force like that gravitation force as well as electromagnetic force. Last point, if it is not a fundamental force, then it do not have equation. So, if the nuclear force is asked, straight away it can be asked as a 2-mark question, write a short note on nuclear force. So, for that, give the definition first and then its characteristics. Okay, have a look, and if you want to take a screenshot for quick revision, you can take it, please. Okay, so it is very easy. After this theory, wait a minute please. We will take nuclear radius, or it having another name, nuclear size, or you can say that it is size of nucleus. Okay, we have seen that equation R is equal to R0, something was there, try to remind that. Okay, I am giving you few seconds to remind that equation. Almost the entire topic is based on that equations only, right? And the equation is, got the point, R is equal to R0 a raised to 1 by 3. Okay, so what was the starting of that size of nucleus? That Rutherford's atomic model, that experiment, alpha particle incident on that gold foil, then there was a study of alpha particle, right? From that study it was clear that positive, that means alpha particles are reflecting back. They are moving backward direction from the center, and it was concluded that size of nucleus is 4 multiplied by 10 raised to minus 14 meters. But there was two things. Which was that? That alpha particle having kinetic energy 5.5 MeV. So in that experiment, the alpha particle having kinetic energy 5.5 MeV, that was fixed. But there was one more conclusion, that if energy increases, then size decreases. Means that 5.5 MeV, instead of that 5.5 MeV, if the energy is increases, there was a calculation which gives radius less than this. There is another thing, it is instead of alpha particle, if they have taken excited electrons, right, that highly excited electrons when bombarded on the gold foil, at that time also the size of nucleus was different, and because of that reason only we have taken this as an average radius, right? And that average radius having equation r is equal to r0 a raised to 1 by 3, where r0 is taken as a constant and a is known as atomic mass. Got it? And from that it was clear that a raised to 1 by 3, r0 is constant, is proportional to r, take 1 by 3 here. So you can say that as atomic mass increases, radius, or you can say that the size of particle increases by power 3. Okay, so this was about quick revision of that nuclear radius or nuclear size. Here, one more thing you have to include, which alpha particle 5.5 MeV. This was the main criteria for that experiment. But if first point, if the kinetic energy increases, size is reduced, means the value 4 multiplied by 10 to minus 14 meter, it is reduced. If instead of alpha particle, if we have taken excited electron, then also the size of alpha particle may be different. Because of that two reasons, instead of that perfect value of radius, we have to take the average radius. Here r0 is constant, value is already there in your assignment. A is atomic mass, right? And from there, it is the relation. As atomic mass increases, atomic mass is directly proportional to r cube. Because of this reason only, its radius, or you can say that size of atom, size of nucleus, not atom, size of nucleus increases. Have a look and again screenshot. Okay, now let us see one more undeleted question from that same chapter, chapter number 13. Okay, and that is binding energy, right? Binding energy. There was one definition of binding energy. What was that definition? The minimum energy at which the electrons remain bound in its orbit. Right? We have taken one example also. Suppose this is nucleus. It is the first orbit, that is n is equal to 1. In this orbit, electrons are revolving. So this is electron, and at that time we got E is equal to minus 13.6 eV. So due to this minus, electron remain present in n is equal to 1 orbit. So minus 13.6 electron volt is a binding energy of electron present in first orbit, or you can say that present in a ground state. So this is about binding energy. And if instead of this, if we are giving plus 13.6 electron volt energy to this electron will come out. So minus 13.6 electron volt, due to this electron was bound in that orbit. But if you are giving energy in plus, then electron will come out. So this energy is known as ionization energy. Is it okay? So two definition. The best example to understand. What is binding energy? Because of that electron remains bound in its orbit, minus sign. If we are taking the same energy in plus, then electron will come out of that orbit, and that is known as ionization energy. Clear? Okay. So this was the explanation about that definition only. But if we want to find by the equation, then we have one equation which was that E is equal to delta M C square. This is Einstein's equation of relativity, which relate two quantities. This E for energy and delta M बोले तो mass defect. What is this mass defect? So mass defect, it is the difference. So it is difference between two. That is mass of nucleons, that is protons and neutrons, minus mass of nucleus. Right? Got the idea? In that regular video, I gave the example of Dhirubhai Ambani, nucleus, and their two sons. That is Mukesh Ambani and Anil Ambani, mind well. Okay? Let us say MP. What is MP? Mass of proton. How many protons are there? That is Z. Plus mass of neutron, that is Mn. How much neutrons are there? That is M. So the masses of protons and neutrons, that is sum of total number of protons plus total number of neutrons minus mass of nucleus, and that is known as mass defect. And this mass defect is symbolized as delta M. And this delta M you have to put in equation. E is equal to delta M multiplied by C square. So you are getting this. That means it is known as binding energy. So from the equation, there is one more definition, one more statement for binding energy. That means energy equivalent to mass defect. What is mass defect? The difference between the masses of sum of total mass of proton, total mass of neutron and mass of the nucleus is known as mass defect, and the energy equivalent to this mass defect is known as binding energy. Clear? One more thing, attached thing. If we are taking binding energy per nucleon, Nucleon means atomic mass A. This binding energy per nucleon gives us stability of element, or you can say that stability of atom, stability of nucleus. And from that we have seen which of the following is the most stable element. Which of that? Iron, Fe, 8.8 MeV. So it having maximum binding energy per nucleon value, and it is considered as a more stable element. Clear? There was a graph that we have seen. From that graph there was two type of particles, two types of elements. There is lighter, atomic mass less than 30, heavier, atomic mass more than 170, and between 30 and 70, 170, they are the stable element. And from that stable element, the most stable element whose binding energy per nucleon was 8.8 MeV. Right? 8.8 MeV. And this energy is for Fe, that is iron, and it is the most stable. Right? Have a look. And on the basis of this, we will solve one numerical from exercise example. But first of all, have a look this. Okay. Now we are going to discuss very easy thing is that I have already solved one example, and that is example number 13.3. Exercise example 13.3. One element is given, and that element is nitrogen. Its mass is given, that is 14.00307 U. That is M is equal to 14.00307 U. What is U? U is atomic mass unit. What is the definition of U? 1/12 part of unexcited carbon atom. Okay? Then we know that mass of proton is 1.007825. How many protons are there? 7. So ZMP is equal to 7 multiplied by, so by the calculation you will get the answer 7.0547775 unit. Got it? Then mass of neutron is equal to mass of neutron. How much neutrons are there? That is A minus Z, 14 minus 7. So again 7, and each neutron consists of 1.00865. So it is 7.060655 U. That is atomic mass unit. And what to find? It is given, find the binding energy in MeV. So again you have to find energy. E is equal to standard equation ZMP plus Mn minus M. All the values are given. It is very easy. Small kids can do. That plus is equal to ZMP, it is here, that is 7.054 775 plus 7.06866 7.6065 6065 minus M, it is here, that is 14.00307. Add this, you will get 14.1543 1543 minus 14.00307 307. So you will get is equal to, that is 0.11236 0.11236 atomic mass unit. But if you want to convert this energy in MeV, then there is a one conversion, unit is converted into MeV by multiplying 931.5. So it is as it is 0.11236 multiplied by, you will get the answer, it is 104.7 MeV. So this is the answer. What is this? It is nothing but binding energy. Got it? And similar to these examples, there are exercise example number 13.4 and 13.5. Based on the same logic, find out mass of proton, mass of neutron, total mass of proton, total mass of neutron, mass of nucleus is given. Just do it. It is the binding energy. In any case, not in this example, in any case, if it is asked to find binding energy per nucleon, then simple, what to do? That is 104.7 divided by number of nucleons, that is 14, divided by 14. You will get the answer again in MeV, right? So this part is there in 13.5. Binding energy, if you want to find, write down up to this. Find up to this. If binding energy per nucleon is asked, then you have to divide by A only. Okay? Have a look for a few seconds, please. Okay. Now, let us see the quick revision of alpha, beta and gamma decay, but with the help of exercise example number 13.6. There are so many parts. A is similar to B, right? Now let us take first B. What is asked? You have to find the alpha decay, beta minus, beta plus, anything. But let us see what is there. In that part, we have to find alpha decay equation, right? And for that, one element is given. It was Ra 22688. is alpha decay, so it is He24. Why He24? Because it is the symbol of alpha. Now, the definition of alpha comes from the general equation. What was there? Atomic number decreased by 2. Atomic mass decreased by 4. Means 88 decreased by 2. That is 86. 86 plus 2, 88 happened. 4 is already there. So atomic mass 2 to 6 minus 4, that is 2 to 2. Then that element is iron. Got it? By this way, you have to find that equation. It is simple, 1 mark question. It can be asked as short questions. Clear? Now, let us see A, B, C, C not D. Right? C is similar to D and we are taking D. What is there? In that, there is beta minus decay. Beta minus means E minus 1, 0. It is a symbol of beta decay. Along with that beta, there is that chargeless, massless and non-reactive particle, and that is, what is called? It is anti-neutrino. Element is given. Which element is there? That is Bi83 to 10. Bi83 to 10. So now beta minus, condition of beta minus. What was that condition? Atomic mass same, that is 210. But minus 1, 83 minus 1, that is 82. So you can say that new element form which having same atomic mass but atomic number less than 1, and that element is PO, polonium. Got it? By this way you can write the equation, right? B and C, they are similar. Now let us take one more example of B plus decay. Right? So there are for B plus E, right? E and F both are same. So here we are taking E. It is of beta plus. Beta plus means E plus 1, 0 plus chargeless, massless, non-reactive element, and this is known as neutrino. Okay, then element is given. Which was that element? C611. That is C611. What is the standard condition? Atomic mass same. That is 11, 6 plus 1. So it will be 5, 5 plus 1, 6. So atomic mass same, atomic number increased by 1, and that element is again that isotope of carbon. Okay, so this is the equation. Simple thing is there. And G, again it is for beta plus. So by this way we will have the revision of that alpha decay, beta decay and beta plus. Okay, what is alpha decay? Simple, we can say that from one element new element is formed which having atomic mass 4 less, atomic number 2 less. Beta minus, new element having same atomic mass but atomic number 1 less. Beta plus, same atomic mass but atomic number 1 more. Clear? This is the end of video number 65 of chapter number 13. Thank you very much. Have a good